blow my nose, then, put this thing on. Okay. Okay, I think we're ready to go. Excellent. Hello, everybody. My name is Ryan Goltry. I'm going to talk with y'all about springtime for code reviews for the next 40, 50 minutes or so. Before we get going, of course, I'd like to thank BSides Nash. They've done a good job of organizing. I had the privilege of helping organize this year, and that was, just a privilege to work with a lot of neat people. And before I came in, they said, would you give this bag away to somebody that, is deserving of a bag? Yeah, you get it. Good. You look most eager. Enjoy. Okay. So a little bit about a disclaimer first. I will be talking about some processes within your organizations of what to do, what not to do, what I've seen work, what doesn't work. If you happen to commit any, career-altering maneuvers or resume-generating events, your problem. A couple of trigger warnings. We will be talking about DevOps and software developers. If that bothers you, there's the door. So a little bit about me. I'm currently a consultant at Defense Point Security. A lot of my bosses happen to show up today. And let's see. So I've been a security architect. I'm a recovering CISO. That's a whole other experience and probably worth another talk in its own right. And, well, I've done a wee bit of coding over the years. I like to travel, see Cadillacs buried in the ground in Texas. Just got back from New Zealand, which was absolutely fantastic. And I enjoy leaning as I go around curves. Excuse me. So a little bit of an agenda. First, we're going to give you a little bit of a story about, my first experience with code reviews, talk about findings and findings management, and what findings mean versus vulnerabilities, at least from my perspective, and then about how to actually get those fixed and, working with PMs and developers and whatnot. So, when I moved here, I got a phone call about 4 months into moving to Tennessee. I had a 4-month-old mortgage, and I was just like, okay. My boss is calling and saying, hey, Ryan, are you a Java architect? Just like, I know Java and I kind of architect. What do you need? He goes, well, we had a Washington Post incident. Can you come and, take a look at stuff with this program and deconstruct it, work with our architects that are maybe just not as bright as you and figure out, what's going on. Are they doing the right thing to fix? I'm like, sure. He's just like, okay, get on an airplane. Your tickets are built. Be at the airport at 1:30. Okay. So get to DC. They give me, the code base, the architects, the DBAs, and say, figure it out. From that, I spent, basically 2 hours, 3 hours working through, the very simple, let's fix the point solution. And then they're just like, okay, we understand that you know your stuff now. Would you do a review of everything else? And I was just like, fantastic. So this is a bit of how that went down. So first, what was a code review? Well, basically it means, getting a second party's eyes on code. It can be from a security perspective. It can be from a functional perspective. Generally, you're looking for correctness. You're looking for, secure coding practices. From a process perspective, it's pretty straightforward. The tricks get into whether you're doing like waterfall or if you're doing DevOps. We'll talk about that in a bit. But really, it's about talking with your developers, talking with your project managers, and then actually getting your eyes on the code. Get tools on the code. Draw out your call sequences so that you know, okay, this is where my model is, this is where my viewer is, this is where my controller is. Understand the architecture of it as it's actually written, as opposed to what's in the architecture documents, because sometimes they're not the same. Excuse me. So, at the end of the day, you're wanting to get stuff fixed. So you're going to come up with a bunch of findings. We'll talk about some of those that you'll find here in a bit. So what do you use? Use a pen, use a paper. You can use tools, static code analysis. You can, use the documentation that's already generated. Basically look at this as a penetration test where you get to actually have all the answers in front of you and actually do a review. Penetration tests are all the rage. And here, you don't have to say, well, is there a SQL injection behind here? You can actually jump to that code and look at all of the database calls. You can look at all of the validation, be like, are they validating right? Are they validating at all? So that's, really nice. So what to look for? Well, you're going to go line for line through the code. It's going to be arduous. It can take some time. But here's a few things that you're going to look for. SQL injection is a great one to look for. Why? Because the PMs love to know if it's there. It's really easy to find. And it's going to make for some really nice impact on your organization. So how many people know what to look for a SQL injection? How many don't? Awesome. So the general problem with SQL injection is when a developer will do string concatenation inside of your SQL statement. So instead of using prepared statements in Java, there's other things in other languages. What they'll do is they'll string concatenate and basically make a more specific SQL statement, such as this one, where you're looking at, selecting a few fields out of a table called Golden Table with an ID equal to param1. If param1 happens to be 5, no problem. If param5 happens to be 5, union select ID and username and password from your user table, you're going to get yourself into a world of hurt really quickly. So what you actually want to, and that's, what the end SQL looks like. You wind up with 5, or you wind up with 5, union select ID from username, password, and a world of hurt. So instead, what you want to look for is a prepared statement in Java. There's other options in Ruby and what have you. But with both of those, you don't wind up with any problem because in those prepared statements, it winds up passing the prepared value, like 5 lines down, set string, that first parameter, as a value instead of altering the string. That's what's really important. Parameter validation is another great find for code reviews. You need to look for basically 2 things: correctness of the validation, if there's any validation at all, and making sure that it's server-side if you're doing a web application. Web developers love doing their validation on client-side. It's better user experience. But in all honesty, that provides absolutely no security and gives attackers a good idea of, what the valid fields should actually look like. When you actually dive down into it, is valid equals true? You should probably write a unit test for things that aren't integers there. I like writing unit tests and integrating them in with the developers. That way they get to see, validations that actually work. And it, gets them in the mindset of, unit tests are actually okay, and it's not just for individual widgets, it's for, little functions that actually, protect the system as well. So cross-site scripting, another one that's more difficult to find, but generally here, pardon me, you're looking for where user input is not escaped as user output. What people often forget is not just within an application, but you can also wind up with cross-site scripting where you pull the cross-site scripting data from another system and into your system. If you got a lot of B2B traffic, maybe you shouldn't be trusting all of the data coming from the other business or from the other section, from the other application. they might do validation as poorly as you do, so why would you want to trust their data? And of course, in the middle of code reviews, something that's not code related, but build process related that you should follow, is take a look at all the components that are actually integrated into the application. Are they using the latest jQuery? Are they using the latest Spring libraries? Are they using the latest packages out for Node or for Ruby on Rails? The nice thing is with Maven and Node, and I believe Ruby as well, it'll actually tell you if you ask it if they're using the right valid ones. Sometimes the developers check, sometimes they don't. It's definitely worth actually checking that all of those are valid and more recent. And lastly, there's plenty of other things to check, but I wanted to hit on these 5. Correctness. You're going to be spending a lot of time, digging through algorithms, making sure that values are actually, getting assigned where they're supposed to be. Not to say that I ever found a place where they're calculating interest wrong, but I found a place where they're calculating interest wrong. So, take some time. You've got plenty of time to make sure that, A, it's secure, but as you get familiar with it, you'll be all like, that doesn't look entirely correct either. Take advantage of that. So, now that you got all these findings from A, your visual inspection, B, your tools, C, probably some things from the interviews, what are you going to do with all this stuff, And these are findings, not just vulnerabilities. So vulnerabilities, things that are causing risk to your organization, and functional problems that probably just need to be fixed, bugs. So best thing to do is, not be a douche. I also recommend not to panic. It's real easy to wind up in a situation where you got, a large number of problems within the code base. I've been dropped on some very immature projects, and all of a sudden I have like 1,000 findings that I'm working with, and I'm just like, well, this program's been alive for 3 years. I think we can spread out fixing all this stuff, and that is okay, because they have to keep going on with the business. The business still has to go on, and we can't shut it down for 2 years because they have 2 years of technical debt. We're going to have to keep going. So, how to get things fixed. Prioritize your vulnerabilities. Prioritize your findings. What's important. SQL injection, you should fix that stuff. Findings, validations, you should fix that stuff. Those are very easy fixes. They are low impact from a coding perspective. They're low risk from actually, causing damage to the system. They're very easy things to test. You can unit test both of them. From other findings that you can find, if they're doing direct object access, be very, very careful. It's still one of the OWASP top 10, but it's one of those things that if they're doing direct object access in a web application, it's probably prevalent through the application, and it's one of those things where you have to be very, very careful that you don't wind up breaking things because you're getting IDs out of the system, and you're trying to make sure that if those IDs are going on to other systems, that you don't break that, cohesion, which would be odd in its first place, but there can also be a bunch of other anti-patterns underneath that. So buyer beware there. Okay, so you're on board with the project manager. You have your prioritized list. The next thing to do is get some street cred with your developers and your DBAs. The best way I found to do this is to actually code with them. Pull up your sleeves and actually, take on, a feature. Maybe it's not even one of your vulnerabilities. Just take on something so that they know that you're bought into the game and you're going to be working with them. You're trying to both get to the same goal. It's very easy to go in there and, tell them, you all got to fix this. Da, da, da. Well, they got features, they got schedules, they got, all sorts of pressure coming from the PM. there's no reason to come in as, the next angry manager or angry engineer from another department. So the best thing to do is to actually be, somebody that's committed and bought in with them. And they really appreciate that. And occasionally, a donut. From a process perspective, the other thing to be wary with the developers is if they are doing DevOps and you're used to working as in a waterfall environment, you need to make sure that you don't bury their processes because their processes will mow you over from a security perspective. They're going to be doing releases every week, every 2 weeks, or they might be doing it every 2 days. There's much, dogma and, pride in being able to do those releases quickly. So start thinking about your findings, your vulnerabilities, your things that you want to have fixed as other features. Get them integrated into the schedule. Get them prioritized right along with everything else. Have the patience with them and be another stakeholder. They'll appreciate that. Okay, so after your first massive fix, you're probably going to wind up in some sort of maintenance mode with the organization doing your project. So, yeah, they're typing away there. So what do you need to do when you go into maintenance mode? Well, you're wanting to mature your processes. You want to get them automated. Make sure that you become as much of the process and getting code reviewed and getting it into a deployed state. In GitHub, integrate yourself into Gitflow. When they see code that might be security relevant, say, hey, could you at least tag me on as a potential reviewer so that I can look at the code and provide some feedback. If you know Git, you're going to get some good street cred from your developers, and that will certainly work. The other thing to do is automate as much as you can. You can pull nightly from their code base and, run tools. Make yourself a little data warehouse. Make sure that, if things start trending too bad, you get involved, get an alert. Maybe even say, no, you can't deploy it. It depends on how much you trust your tools. There's some things that tools find very well. There's some things that they don't. Tools I have yet to find actually do validation checks well at all. If a vendor wants to tell me otherwise, great. I'd love to see it. And of course, work with them continually to prioritize work. Find new findings, get them integrated in as features, and keep trucking along. You're not just another stakeholder. Keep going along on the DevOps train. On Waterfall, you got a little bit more time, but you still got to stay involved. So, final tips, and just to reiterate, patience and endurance. These are going to be long slogs. If you got 1,000 findings within a big stack of code, it's going to take some time to get through, and that's okay. If you find some really critical findings, you might want to stick them on your risk log because you're not going to be able to get to them as quickly as some others. There's some things that are going to be so small, silly typing things that you don't want to necessarily throw on your risk log, but you eventually want to address. So keep that in mind. And of course, be a teacher. We always need more security professionals. Grab a developer or 2 or 3 and teach them about what you're doing, and they might be able to bring 2 or 3 of their own, and that's kind of good. Of course, I pull a lot of things from OWASP. Everybody should read OWASP. The top 10 for 2017 should be coming out of beta very soon. It's already released. It's changed a little bit, but still basically the same from 2013. So that's worth it. And finally, special thanks to a bunch of people. E. Medina K. Weiss, my wife, she's awesome and puts up with my crap. And a bunch of people from Twitter land that have just been, good instructors for me over the course of the past 2-3 years that I've been in Twitter. So a hat tip to them. So, are there any questions? Yes?
Do you recommend any particular frameworks for testing?
I endorse using charm and, soft skills. From that, it's, brute force, tools, and, knowledge of OWASP and what, the real vulnerabilities look like, and going from there. Any other questions? Well, thank you very much. Appreciate it. Thank you.